Math and Leonardo da Vinci's art development. Leonardo da Vinci used his understanding of mathematics and geometry to produce some of the most notable Renaissance art. Da Vinci was born in 1452 in Anciano, Italy, where he grew up and began his career. Da Vinci combined his understanding of math and the arts to produce masterpieces. He used the mathematical principles of linear perspective, which consist of parallel lines, a horizon line, and a vanishing point to create the illusion of depth on a flat surface. Da Vinci incorporated various principles of geometry in his artwork while producing world-renowned pieces. He used formulas such as the golden ratio, better known as the divine proportions, to create grand works like the Vitruvian Man and the Mona Lisa. According to mathematicians, the golden ratio is a special number equal to about 1.618, which appears in geometry and art. This formula is found when a line is divided into two parts, such as the whole length of the line divided by the long part of the line is also equal to the long part of the line divided by the short part of the line. Da Vinci primarily studied geometry in his math career, and his work with angles and triangles that helped him achieve excellent proportions in his artwork. Perspective was one of the most successful techniques by which Da Vinci created realistic backgrounds in his art. This method uses steady line work to assemble shapes that build off of the same point. The general theory of linear perspective states that the projected line, which takes points x of the object, which is in 3 space, and plots them as points p on the drawing plane. The function used for this certain type of equation would be p equals f of x. It has the property that points are mapped to the points and lines to lines. However, parallel lines in 3 spaces that are not parallel to the drawing plane must be drawn to converge at their vanishing points. Thus, the correspondence between lines and points in 3 spaces, lines, and points on the drawing isn't perfect. Thus, if L1 and L2 are parallel lines in 3 spaces, then f of L1 and f of L2 are lines that intersect at V, their vanishing point. However, L1 and L2 don't intersect at any point. Lines AB, CD, and E', V' are parallel. Their projections are A', B', C', D', and they intersect at point V', the vanishing point, since it has no corresponding point in 3 spaces. Linear perspective allowed Da Vinci to create natural-looking backgrounds by fooling the eye of the viewer. The geometry behind his paintings allowed Da Vinci to become a pioneer in the Renaissance art and design field. The golden ratio is paramount to Da Vinci's achievements in natural proportions. According to art historians, Da Vinci created the illustrations for De Divina Proportione, a book about mathematics made in 1498. The book was about mathematical proportions, which it heavily refers to the golden ratio and applications in art and architecture. Da Vinci's use of the golden ratio is evident in his work, even before he collaborates with Pacioli, who founded this technique. By examining Da Vinci's most famous works, the geometry used in them is extremely apparent. When studying the Vitruvian Man, historians found that the geometry used in the construction of it shows that the circle goes through the top vertex of a 45-degree rotated square. The radius of the sphere should have the value of 2.5 plus 1 divided by 4, which equals 0.604, which is closely measured to the value of 0.606 to approximately 0.609, then its golden ratio average of 0.618. The circumference touches the soles of the man standing upright and the fingertips at the height of the top of the head. Since the allowable range for the radius of the circle becomes much more restricted by the conditions, it indicates that Da Vinci intended to introduce those additional conditions. Da Vinci utilized circles and squares to properly build his drawings to achieve accurate proportions. This mathematical formula was one of the greatest tools for the success as a Renaissance painter. Da Vinci used mathematics to find missing angles in triangles. He used this information to improve his artwork and help create techniques of design. In the Vitruvian Man, there are 2 triangles, A and B, which are present in the man's arms that touch the 2 corners of the circle. The given angles in side triangles A are 10 degrees and 120 degrees, and in B, the 2 given angles are 70 degrees and 48 degrees. A key component for determining the missing angles inside of a triangle is knowing that all angles add up to 180 degrees. To solve for the missing angle in triangle A, you need to add up the two given angles, which comes out to be 130 degrees. Following that, you then subtract your answer from 180 because it's what all triangles must equal. After subtracting the two numbers, the missing angle in triangle A comes out to be 50 degrees. You then follow the same process for triangle B by adding up the two angles of 70 degrees and 48 degrees, which equals 118 degrees. To find the solution, you then subtract 118 degrees from 180 degrees to find the missing angle of 62 degrees inside of triangle B. Leonardo da Vinci used linear perspective to create photographic backgrounds in his artwork, which contributed to the realistic nature of his art. He utilized the golden ratio to construct natural proportions and develop lifelike human bodies. Finally, Da Vinci employed his mastery of geometry in triangles to find missing angles in his pieces. Da Vinci used his understanding of mathematics to advance realism within Renaissance art and create pieces that are still studied in school today.